Okay. So, in light of the demonization is coming to a close, and our heart moon this time of the year, it always I'm always thinking about all of the medicines that we use to help our vascular system. This is the time of the year, our demon are ripening, and we utilize them for medicine. We don't, not the berries. The berries are just a good little snack. The leaves of this, and to a lesser degree the roots, but mainly the leaves, because this plant is an evergreen. It will it'll keep its leaves all winter, sometimes for a couple of years. And so you got to actually find the older leaves that are the most damaged and the most stressed, and that, they've been through a lot. Those are the ones that we have to find to utilize as medicine. They're going to have the maximal medicinal potential in the leaves that have overcome the most amounts of stress. So we use the older leaves as medicine. And it's always incorporated. This is the time of year that I think about how, when we make our heart medicine, our demskikke, which is a mixture. It's a very, very great mixture. Strawberry leaves are one of the things. Striped maple is another one. Komnagawash, the mountain ash. We have okoemnatik, the black cherry. We have sasoemnatigons, choke cherries. We have the pin cherries. We have all the different types of cherries that we mix in there. Even the violets. One interesting thing too is that all of the barks we get now, so the striped maple bark, we could get it now. It's very easy to harvest all the different types of barks. And then, now we could pick, or closer towards the fall, we could start getting the strawberry leaves from previous years that have overcome the most amounts of stress. We could get in the fall. But right now we could get the seeds, and be responsible for the collection and distribution of these seeds, to help make sure that we're there, in constant reciprocation with all these different medicines, helping them just as they're helping us. And so this is the time of year, that my mind is just really on cardiovascular disease. So that's what I wanted to share a little bit about today, is just when we're talking about cardiovascular disease, it is the number one killer of Indigenous people above all else, above all other what we would consider to be all-cause mortality, everything that can possibly kill us other than an accident. Cardiovascular disease is the number one killer. And so I, wanted to be able to spend some time with us today to be able to understand that completely. How does it happen? Where does it start from? How do we prevent this from happening? The number one cause of death other than an accident. So it's a big one. And so, medicine plays a really important role. But, the mechanism, the plant chemical mechanism of these plants is to reduce inflammation, the damaging effects, the toxic effects of glucose. And a lot of this is really, really understudied. Totally understudied. These are done in petri dishes. These are done on lesser animals. And so a lot of this is, as far as the scientific rigor, really doesn't say much at all. I really hold my experiences in Indigenous communities over the past 9 years or so to be, what I really rely on in teaching about these medicines, just because the science is not there. It's really not there. And so one of the things that we see when people start to utilize this medicine is dramatic reduction in vascular inflammation. So vasoinflammation that you could see like in the varicose veins or spider veins will be gone the next day. People who are diabetic, or not even diabetic, but just bruise easy. If you bruise easy, that is a really good sign. And if it takes forever for that bruise to be able to heal, that is a very good sign that your vascular system is under huge amounts of stress. The number one stress to your cardiovascular system is sugar. When your blood sugars are above 9, 10, that's when endothelial damage occurs. That's when your blood vessels are being destroyed. And so by far the primary insult to your cardiovascular system is when your blood sugars are too high, when you are not able to control your blood sugar. In other words, when you are insulin resistant. So after the whole insulin resistance cascade begins, that's the state at which our blood vessels are under a lot of stress, under a lot of insult. And you could see some really dramatic, ability to heal, a reduction in that. But obviously, the medicine is only able to do so much in the presence of the insult. And so I want to talk to you a little bit more about what this insult is and how it works. So we have our beautiful heart and blood vessels. Inside of your blood vessels, you have this little hair-like substance. It's called the glycocalyx. This is a very recent sort of phenomenon that we discovered. So you have this glycocalyx on the inside of your blood vessels, and it's big. This is what is responsible for protecting the inside of your blood vessels, the actual vessel itself. Because if you look at the actual vessel itself, the furthest, the what is on the inside part of your blood vessel is called the endothelium, made up of a lot of different endothelial cells that all stack up on top of each other and form that inner membrane that we call your endothelium. But your glycocalyx is there. These hairs are there to help protect that. And so in the pathology of cardiovascular disease, how this disease begins is because that endothelial cells are damaged. And when they're damaged, they shrink, they get squashed. And what happens is you have gaps in between the endothelial cells. And those gaps are what's responsible for when the junctions between those endothelial cells is increased by damage, by insult, by sugar, then the LDL cholesterol particle, LDL particle containing cholesterol gets behind the wall and becomes oxidized or glycated, and other LDL particles will get stuck to it. So it gets glycated, it gets very sticky. Other cholesterol particles will get stuck to it, and they'll eventually start build this little deposit, and there'll be immune responses and foam cells and the beginning of an atherosclerotic plaque or streak or blockage. It happens because the endothelial cells are damaged by sugar. They shrink, then the LDL can get in behind, and sugar causes the glycation of it, so it becomes sticky. Then other particles are attracted to it and will get stuck to it and will become glycated, will become oxidized by too much sugar inside of your blood. And so this whole cascade of events really starts because these endothelial cells are exposed to sugar. So how do we protect them from being exposed to sugar? We have the glycocalyx, the little hairs that protect it. But this is what happens when we have carbohydrates. This is what happens when we have sugar. That hair, that glycocalyx that's protecting those endothelial cells is destroyed. And after a few hours, it is gone. After a few hours of not even a high carbohydrate meal. I think some of the studies that I was able to look at were looking at 50 grams of carbohydrates, which is a very pretty low carbohydrate meal by today's standards. We're used to having over 400 grams of carbohydrates every single day. So you can imagine we're basically living our lives with no glycocalyx, with an exposed endothelium. And when the sugar hits those cells, it destroys them, it shrinks them, and allows the LDL particles to get in behind. And it's the sugar that allows them to be glycated and to become sticky and to attract other ones. And so the whole pathology of cardiovascular disease has nothing to do with cholesterol. It has everything to do with sugar and sugar's effect on the glycocalyx, shrinking it down to nothing, exposing the endothelial walls, sugar destroying those endothelial cells, causing them to shrink, increasing the junctions between the two. And in a carotid bifurcation, the branching of your arteries, this is the only place where atherosclerosis will occur. One of the only places. The most susceptible region is where the force is slowed. The sheer force and strength of the vasculature of the blood flowing through the system is slowed, and just like in a river, it makes this little eddy. And it's only in that eddy is the LDL particles going slow enough that they'll be able to sink in behind the wall. And these little eddies are dramatized by high blood pressure. And high blood pressure has its roots in insulin resistance. And so it is a combination of, or just totally looking at the overconsumption of sugar and carbohydrates is the main contributor in the pathology of cardiovascular disease. It has nothing to do with cholesterol at all. The metric that we use to be able to measure high cholesterol, the LDL particles, it's so inaccurate as well, because those LDL particles are only the particles that are carrying the cholesterol around your body, because cholesterol is fat. Fat is immiscible in water, and so your body needs to create these little proteins, these little buses that transport the fats around your body. And so it's just that those LDL particles aren't just taking cholesterol everywhere. They're taking fatty acids in the form of triglycerides and depositing those in muscles so they can be burned for energy. And so LDL particles are doing lots of different jobs. And so they are what sink in behind the wall. And what happens when we go in for heart surgery, we take out, the surgeon is able to take out, and you could see inside of the plaque deposits, it's just a bunch of fat. And it's really easy to think that you're eating too much fat. But when you realize that cholesterol makes up by weight over 50% of every cell that is inside of your body is made up of cholesterol, when you realize that every hormone is built off of a cholesterol backbone, vitamin D, testosterone, estrogen, these are all built upon cholesterol. And when cholesterol is lowered, there is a detrimental effect on the structure and integrity of every cell inside of your body, and in the ability to produce those hormones that really are responsible for making us who we are. And so all of this effort to lower cholesterol is one of the worst things that we can consider. Your body makes the amount of cholesterol that your body creates. Yes, your liver creates cholesterol. That is determined by your genetics. It is a gene inside of your liver called HMG-CoA reductase that creates cholesterol. And so if you eat a lot of cholesterol, your liver doesn't have to make so much. You stop eating enough cholesterol, your liver is going to have to make more, but you will always bump it up back to baseline no matter what, unless we're taking a statin drug, which inhibits the amount of cholesterol that enzyme in your liver is able to make. And so why would we want to do that anyways? And so it's just kind of interesting to think about, the demonization of saturated fatty acids and cholesterol in the cause of heart disease when they have absolutely nothing. There's no mechanistic, it makes no mechanistic sense. And even when we're looking at statin drugs, you could look at statin drugs. They are 30% effective to be able to lower your risk of a heart attack or a stroke. There is a consequence that I alluded to earlier to taking statins, but 30% risk reduction, that is fantastic. But the problem is that the mechanism of statins is the reason why they have such a dramatic ability to reduce your chances of getting a heart attack or a stroke is not because they lower cholesterol. It's because they have an anti-inflammatory effect on the endothelial cells. So they help that barrier to become less susceptible to the toxic effects of glucose. So we take this drug and it seems like a good thing, but no education as to the cause of how this begins. This entire cascade of events, of atherosclerosis, of an atherosclerotic plaque, of a blockage in your blood vessel, the mechanism of it has everything to do with the amount of sugar that's inside of your body. The damaging effects of sugar to the endothelium only occur after you have effectively wiped out the glycocalyx, which is just, a few carbohydrates away. And then your sugar, in order for there to be enough sugar inside of your blood to cause damage, will occur anywhere north of 9 millimoles to 10. That's when endothelial damage occurs, when your blood sugars are above 10. And so if we are consuming a diet that is free of carbohydrates, free of sugars, there is nothing that will get your sugars to the point where they will be above even 8. And so this is why, even in the Anishinaabe language, there's no way that we could describe heart disease or a heart attack, because they never happened before. Why? Because we come from a people that was eating a biologically appropriate diet. We were eating in such a way that supported our biology. What does our biology say we should be eating? Is a diet made exclusively of animal products, which is meat and fat. So outrageous amounts of saturated fats. That's what our bodies are designed to eat. And you can only see disruptions when we start to incorporate plants, when we start to incorporate carbohydrates. That's when damage occurs. And so it's just really, really amazing and interesting to be able to look and see what happens. And at what level that it happens at. Physiologically unattainable levels of blood sugar when you're eating a biologically appropriate diet, a culturally appropriate diet. You will never expose your endothelial cells to sugar and to sugar concentrations that are high enough to actually cause damage to those endothelial cells. So to never allow LDL particles to sink in behind the wall and to become glycated. Glycation is not going to happen. That's just the accumulation of sugar, of glucose, to the LDL particle. And so they will never become glycated because there will never be enough sugar to be able to create that environment. And we're not going to have the high blood pressure caused by insulin resistance to create the strong eddy in a carotid bifurcation. And so LDL particles will never be able to sink in behind. And there will never be an immune response to a bunch of glycated proteins inside of the endothelium or behind the endothelium, because they won't be there. So yeah, it's just super interesting to look everywhere that I look. Everything that I see points to the elimination and complete absence of carbohydrates and sugar from when we disobey that biology, the dramatic consequence to that. And then, it's just super interesting. You look to the medicines that help support that as well. And the medicines that you look to, all of the different medicines that we use are all doing one thing. They're just reducing the toxic effects of sugar to the endothelium. So what are we going to do? Just drink medicine all day, every day long, all day long, every single day for the rest of our lives? Or are we going to reduce the amount of sugar that we're eating so that we'll never need to have this medicine? So it's just like, it's a respectful thing too, to the plant world, to not look at plants and say, okay, well, I have 2 liters of Pepsi that I need to drink today. I need to make sure that my blood sugars are above 15 for 8 hours today. And so, I'm going to take this medicine to make sure that there's, to lessen the toxic effects of this 2 liters of pop that I have to eat, or this giant plate of pasta that I have waiting for me at home tonight, or the sandwiches, the muffin that I have to shove in my face as soon as I wake up every day. And then to say, hey, you know what? Maybe I'm just going to do what I need to do. I'm going to listen to my biology and eat appropriate to that, and prevent the need from ever needing medicine. And so, it's just looking at the, cardiovascular disease. This is super fun and interesting to me. This is where my research has brought me so far. So this is my cry, or my effort, to reach out to peers and other experts in this field of nutrition and prevention of chronic disease, to be able to say, hey, I want to do what I can to be able to help in this chronic disease epidemic that Indigenous people are in, Canada and the US entirely as well. And I want to be doing my part with the knowledge and gifts that I was given to be able to look and understand the pathology of these diseases and say, hey, is this right? So if I'm wrong, correct me if I'm wrong. But as far as I'm concerned, this has been pretty rock solid. And so I invite differences in opinion. I want to have this conversation, and I want to get to the bottom of what is causing chronic disease, and the leading cause of death in my community and with my people. And right now, it's looking like any amount of sugar is going to be contributing to that risk, that threat. And I want it gone. And I want us to be able to fully identify the truth. So correct me if I'm wrong, or support me if I'm right. There's a little bit of juice on cardiovascular disease, how it begins, what we need to do to avoid it. Yeah, it's pretty well all I wanted to yell at you guys about today. Share it up. If you know somebody who's in the field of nutritional research, if you know somebody, I want to visit, I want to have these conversations, and so share it with them. Thank you. Miigwech. We'll see you guys later. Bam, peace.